Welcoming you all, I am Dr. S.Vinotha, working as lecturer, PG and Research Department of Chemistry, Seethalakshmi Ramaswamy College, Trichy. In this video, I am going to discuss you about the basic principles of volumetric analysis. Before moving on to the discussion, we have to know that what is volumetric analysis. Volumetric analysis is a qualitative method determines the concentration of the substance. It is commonly used in various places such as chemistry, pharmaceutical, and environmental labs. Let us see the definition of the volumetric analysis or titrimetry. Determines the substance concentration by reacting it with a solution of known concentration. This process is called titration. Before moving into the topic, you must know some basic things about volumetric analysis. The first one is analyte. Analyte is nothing but the substance which is going to be analyzed, which is usually taken in a conical flask. For example, in an titration, to determine the concentration of the unknown acid, the acid would be the analyte. Second one is the titrant. Titrant means burette solution whose concentration is known. It is added to the unknown concentration during the titration. For example, the solution of known concentration base like NaOH would be the titrant. Third one is the equivalent point, which means the titration has fully reacted with analyte, resulting in a balanced reaction. It occurred before the end point. The fourth one is the indicator. Indicator means it indicates the end point of the titration. Usually, color change occurs. From that, we can understand that the reaction get completed. Let's see some of the importance of volumetric analysis. It is essential for precise concentration measurements in various fields. In pharmaceutical industry, it is used to analyze the drug purity and concentration. In environmental monitoring, it is used to determine the pollutant levels in water and soil. In food industry, it is used to determine the quality and composition of the food products. Let us see the fundamental principles of volumetric analysis. Volumetric analysis uses precise volume measurement to determine an unknown concentration by reacting it with the known concentration. There are three basic principles of volumetric analysis. One is stoichiometric, concentration, and volume. Stoichiometric means the balanced chemical equation is crucial for the calculating the unknown concentration. Concentration means the titrant solution concentration must be accurately known, typically prepared by dissolving a known weight of a pure substance in a specific volume of the solvent. Volume. Volume means the volume of the titrant solution needed to reach the end point is precisely measured using a burette. Let us see the types of volumetric titration. Different types of volumetric titration are used based on the nature of the reaction and the analyte being determined. There are four types of volumetric titration: acid-base titration, redox titration, complexometric titration, and precipitation titration. Let us discuss one by one in detail. Acid-base titration, a reaction between an acid and a base. Common indicators used for this type of titration are phenolphthalein, methyl orange, etc. The example for this type of titration is strong acid, that is HCl, and strong base sodium hydroxide react to give sodium chloride, that is salt plus water. In this type of titration, we can determine the concentration of the HCl. Second one is the redox titration, a reaction involving the transfer of electron between the titrant and the analyte. Here, the common indicators used for this type of titration are methane group, starch, diphenylamine, etc. Example for this type of titration are ferrous sulfate react with potassium permanganate. Here, oxidation and reduction take place simultaneously. Fe2 plus ion get oxidized to Fe3 plus state. Here, MnO4 minus get reduced to Mn2 plus state. Third type of titration is the precipitation titration. The reaction involves the formation or disappearance of the precipitate. Common indicators used for this type of titration are silver nitrate, methyl orange, fluorescent, etc. Example for this type of titration are silver nitrate react with sodium chloride, which gives silver chloride plus sodium nitrate. In this, at the end point, silver chloride forms the white precipitate, which indicates the precipitation titration. Fourth one is the complexometric titration. The reaction involves the formation of complex. Here, metal indicators are used to determine the endpoint. Common indicators used for this type of titration are erichrome black tea, that is nothing but EBT, and muraxide, that is commonly known as ammonium perchlorate, and calmate, etc. Example for this type of titration is determination of calcium and magnesium in water, that is how much the water contains the calcium and magnesium ion. Hardness of the water can be determined. Let us see some basic requirements for volumetric analysis. To get accurate result, we must need some precise equipment and proper procedure. Things needed for the volumetric analysis are volumetric flask, which is used to prepare the standard solution of known concentration. Burette, precisely dispensing the titrant solution. Pipette, accurately transferring the analyte solution. Beaker, used for holding and mixing the solution. Indicator, used for signalizing the endpoint of the titration. Preparation of standard solution. Standard solution is nothing but the solution of known concentration, which is important for the volumetric analysis. Before preparing the standard solution, three steps should be followed: weighing, dissolving, and diluting. Weighing is nothing but accurately weighed a known mass of the pure substance. Then dissolve the weighed substance in a specified volume of the solvent. Then it is diluted to the desired concentration. After completing these three steps, the standard solution is prepared. Once the standard solution is prepared, we can start the titration with the unknown concentration of the solution. Once the titration is started, then how can we find out the endpoint? By using the specific indicators, we can identify the endpoint. Endpoint means it shows the color change, which indicates the completion of the reaction. In normal method, visual indicators are used to visualize the color change of the solution. In case of instrumental method, some instruments such as pH or conductivity meters are used to determine the endpoint. After completing the titration, let me move on to the theoretical part, that is calculation and interpretation. In that, the concentration of the analyte is determined using the volume of the titrant used and the known concentration of the titrant. The titrant equation, the balanced chemical equation and stoichiometry are used to relate the moles of titrant to the moles of the analyte. Data analysis are analyzed to ensure the accuracy and precision, and any potential sources of errors are considered. Some common concentration units used for the volumetric analysis are molarity, normality, molality, parts per million and parts per billion. Molarity means moles of solute per liter of the solution. It is usually indicated in the letter capital M. The formula for molarity is moles of solute divided by liter of the solution. Second one is normality. It is defined as the equivalent weight of the solute divided by liter of the solution. It is usually indicated in the letter capital N. Equivalent weight of the solute divided by liter of the solution. It is used for acid, base and redox reactions. The third one is the molality. Molality defines the moles of solute per kilogram of the solvent. It is usually indicated in the letter small m. M which is equal to moles of solute divided by kilogram of the solvent. It is usually used in temperature dependent scenarios. Parts per million and parts per billion. Parts per million is indicated by ppm. ppm means milligram of solute per liter of the solution, and parts per billion ppb microgram of the solute per liter of the solution. Let us see the application and limitations of volumetric analysis. Volumetric analysis is widely used in various fields, but it has certain limitations. The application of volumetric analysis determines the concentration of acid, bases, oxidizing agent, reducing agent, and metals. The limitations of the volumetric analysis: it cannot be suitable for very dilute solution or reactions that are very slow or incomplete. These are the limitations of the volumetric analysis. Hope you all like this video. Thank you for your patient listening. Thank you.